Hello everyone. In this video, we will continue to examine topic 7.2, nuclear reactions, and in particular, the relationship between mass and energy. So finally, here we are. Perhaps you've skipped directly to this particular video. Perhaps you've come in sort of at this particular point. But in either case, mass and energy are equivalent, okay? And this is a consequence of the various postulates of the special theory of relativity. And it has the result that for the rest mass, E is equal to m naught times c squared, okay? To tell me the energy of a system at rest is to tell me the rest mass, just scaled by a factor of c squared. So E divided by c squared is m naught, and m naught times c squared is E. Now this idea that mass and energy are equivalent has a number of interpretations. And actually, in the traditional version of this, the traditional presentation, almost always what is given is incorrect. And I'm going to give that version as well, but also a more in-depth, more correct version. And I will switch back and forth, in part because the traditional presentation of this is not just wrong, but it gives you some very weird results if you are not paying attention. So the traditional interpretation of this equation, E equals m naught c squared, or the equivalence of mass and energy, is that in some sense, energy can be converted into mass, or that mass is a form of energy. You see this when people discuss the energy released, for example, in an atomic or a nuclear bomb. Often they will describe what is happening as that some of the mass of the part of the bomb is converted into energy, and that is what is happening. This is a very useful idea in different circumstances, and even I will slip into it every now and then, in part because you can solve a lot of problems, sort of physics problems, by simply saying, all right, how much mass was lost, therefore how much energy was gained, or vice versa. Unfortunately, this is not correct, and it can get you into trouble in a couple of situations. The version that I would encourage you to consider is one in which you sort of directly tie this concept of mass, and one of those concepts in particular, to the concept of energy. And so here's the correct version. The inertial properties of a system, that is, how difficult it is to accelerate, depend on its total energy content. If you add energy to a system, you make it harder to accelerate. So the energy is related to the mass in that sense. Another version of this is to say that mass is a measure of the total energy content. So it's not that we're somehow converting energy into mass or vice versa. And if you think about it, that can't possibly make sense, okay? That idea doesn't make sense. Energy is a number. Mass is stuff, right? So we're not actually converting energy into mass. What is truly correct about mass-energy equivalent, or the full version of mass-energy equivalence, is that the inertial properties of a system, that is, the mass, depends on its total energy content. If you decrease the mass of the system, you decrease its total energy content, and mass is a measure of the total energy content. That is the sense in which they are equivalent. They are not identical, right? They have different units. But to within a conversion of c squared, the number will be the same. And we will see lots of ramifications of this interpretation as we move forward. One thing to note, I'm still going to use this, okay, at times. And I'm going to use it because it is a much easier and simpler principle to apply to different circumstances. But every once in a while, it will lead you astray.